Hello, ladies and gentlemen. My paper is Sparse algorithm for OFDM and water acoustic channel estimation, and I am the author of the paper, Tieliang. And first, let me introduce the paper's abstract. Channel estimation is very important and challenging for underwater acoustic systems that are OFDM technique. The conventional methods are not appropriate to the sphere frequency selective feeding channel. Also, current channel estimation algorithms do not use the sparse characteristics of the UWA channel efficiently. In this paper, a novel algorithm about channel estimation is addressed that applies channel sparse features. First, LS algorithm is used to get the pilot channel valuation. Secondly, the sparse degree of channel is estimated through DFT for noise reduction processing. Then the autocorrelation matrix of the channel is obtained approximately. Finally, a preliminary calculation of the error threshold is required. And the high-quality data subcarrier channel impulse can be estimated by the pilot system symbols through using the OMP algorithm. In terms of simulating, we study the performance of the system through BER and the constellation diagram, and it is indicated that the new method has excellent performance at noise computation. So it is very important that the method can be implemented in OFDM systems. The paper's first part is introduction. Due to the large delay, time varying, and multipass, the channel of UWA is one of the most challenging various channels. Recently, the UWA channels are proved to have sparse feature, namely that both the energy of the channel is focused on a few channels. Considering the sparse nature of the channels, many sparse methods about the channel estimation have been addressed. OFDM technique has low computation cost and can resist frequency selective feeding. This promotes the application of OFDM in various underwater acoustic communication systems over the past decade. Sparse estimation methods based CS are widely employed. There are many algorithms about CS. BP and OMP methods belong to greedy algorithms among them, and two-way studies as a solution to the UWA channel estimation. In the literature falls through exploiting the sparse feature of the channel, some estimation algorithms described have been mainly proposed. BP and other OMP methods have been varied, and through simulating and experimenting, it was indicated that BP has better performance than OMP for the UWA channel. However, the BP method has much higher computational complexity. Through comparing conventional CS methods, field tests have been done by exploiting joint sparse nature about the continuous OFDM plugs. In the experiment, the authors verified the superiority of the method. In addition, the LS method used is greatly affected by noise for channel estimation in the system. To solve the above problems, this paper proposes an optimization algorithm based on CS about the noise of the LS method. Combined with CS algorithm, pilot dirt are used to optimize the LS channel estimation as the receiving end, simulation results, and theoretical analysis indicates that the impact of Gaussian white noise can be reduced in the process of the channel estimation. And the paper proposed three kinds of models. The first is signal and system model. The first model is UWA sparse channel model. And we usually use the model of time varying channel for underwater acoustic communication. And the second model is OMP algorithm model. OMP is one algorithm about CS theory that is given in the form as follows. BP algorithm and OMP algorithm are two typical search optimization algorithms in common use. For the second algorithm, in order to achieve sparse recovery, the minimum sparse estimation can be obtained by optimizing the constrained norm problems. And the third model is system model of OFDM. In one OFDM circle, XK represents the complex information code to be transmitted on the case subcarrier. During endpoint IDFT, the following time domain expression will be got. To the OMP algorithms, the sparse degree is unknown, so we need to know the threshold value epsilon that determines the time of iterations on the basis of LS algorithm. This paper proposes an innovative algorithm which uses pilot frequency to set the threshold. And the paper's third part is estimation of error threshold values. The pilot channel estimation is obtained by LS channel estimation. These data are then carried out NP point IDFT to obtain the point time domain sequence as follows. Then denoising is performed for equation 10 and L. Effective passes are reserved for each response value and the rest are set as 0. If the delay information of the channel is unknown, the circular prefix can be retained or the value of L can be determined by setting noise threshold. NP point time domain sequence is obtained after denoising is given by the following equation. M denotes the sum of channel estimation error and Gaussian white noise, and it can be acquired. The noise M can be assumed a multivariable normal distribution with 0 mean value, and its covariance matrix can be expressed by the following equation. And in the above equation, where beta is constant and its value is related to the specific modulation mode as NR responds the signal to noise radio. According to the knowledge of probability theory, generally satisfies the following formula. To sum up, the error tolerance value in epsilon can be approximated as follows. And the papers was passed as simulation results. The detailed system specifications of the simulation are shown in Table 1. In the simulation processes, the performance of the new method is tested mainly by detecting the BER curve and constellation diagram. Assume that time synchronization and frequency synchronization is ideal. In addition, in order to highlight the performance of the new algorithm, the additive white Gaussian noise is the only factor affecting the performance of the algorithm in UWA channel. The OMP algorithm proposed in this paper can use the sparse characteristics of UWA channel to overcome the noise. In order to verify the performance of the new algorithm in channel estimation, Figure 1 shows the bit error rate curve comparing of the results of the LS algorithm and the OMP algorithm. Because the traditional LS method cannot eliminate the Gaussian noise of the receiver, the bit error rate of the system will be reduced seriously. In addition, the above conclusion can be verified according to the constellation diagram in Figure 3 and Figure 4. Pilot subsquares are applied to roughly estimate the channel based on OMP algorithm, so the number of the pilot subsquares has some influence on the new algorithm. The influence of mid-error rate curve on the number of different pilot subsquares will be simulated and analyzed, as can be seen from Figure 2. The system performance will decrease with the reduction of pilot frequency. This is because the frequency interval of the pilot frequency has a great influence on the LS algorithm. That is, the LS algorithm will affect the calculation of the threshold epsilon. Conclusion. In this paper, a new UW channel estimation method based on OMP algorithm is proposed by using the sparsity of UW channel and CS processing method combined with LS method. The algorithm can make the receiver estimate the channel pulse accurately and greatly reduce the Gaussian noise. Both theoretical analysis and simulation results indicate that the algorithm is effective in reducing Gaussian noise and the complexity is low. In conclusion, compared with the traditional LS and method, the improved method is more practical for high-speed real-time OFDM communication and under acoustic systems. And this is my report about my paper. And my report is talked mainly about the OFDM systems of UWA channel estimation method and the OMP algorithm is posted in the paper. And this is my own report. Thank you.